Hello Ninja Warriors, welcome to yet another power packed session, and in today's session we are going to discuss all the problems of limits chapter from the January attempt from JEE Main 2024. Okay, so as you can see, because you always talk about weightage, right? So weightage of this particular chapter is from limits you can expect one question minimum from this chapter alone, because in January attempt 11 question, so approximately 1.1 question were asked from this chapter. April attempt also 1.1. Okay, nature of this chapter, you know, it is not that difficult, not that tedious, and it is the backbone of continuity and differentiability to upcoming chapters. Okay, so now the question says fx is given in the form of inverse trigonometric functions and fractional part of x, and they are saying L and R be left hand and right hand limit, and we need to figure out the value of 32 by pi square L square plus R square. So overall question is all about calculating two different limit. First one will be right hand limit, will be limit x tend to 0 plus. Okay, so cos inverse 1 minus fractional part of x square, sine inverse 1 minus fractional part of x whole upon fractional part of x, let's take common, 1 minus fractional part of x. Okay, so now for the right hand limit, the moment you put x equals to 0 plus h or 0 plus, basically 0 plus only, your fractional part of x becomes x only. You know this is common sense. If I say that your x is 0.2, what is the fractional part in it? Ma'am, it is obviously the 0.2 only. Same, 0.3 ka fractional part will be 0.3 only. So fractional part of x will become x if your x is fraction between 0 and 1. So clearly fractional part of x will be replaced by just simple x. So cos inverse 1 minus x square, sine inverse 1 minus x, x 1 minus x square. R will be equals to limit x tend to 0 plus. Okay, all right. Then we are having, now understand, if you put x equals to 0 over here, it will fetch you pi by 2, right? Sine inverse 1 is pi by 2. This will become 1. Okay, so we are just, so this is pi by 2, I'm putting the value. Now we are just left with cos inverse 1 minus x square by x, because the moment you put 0 in numerator and denominator, it is becoming 0 by 0. So what we can do is, we can tackle this by using cos inverse x 1 minus x square, I can put as theta. So 1 minus x square will become cos theta, and 1 minus cos theta becomes x square. So x will become square root 1 minus cos theta. So R will be equals to limit x tend to 0 plus theta up 1 minus cos theta, or rather, if here only x will be square root 1 minus cos theta is root 2 sine theta by 2. Perfect. So this is root 2 sine theta by 2. Pi by 2 is already there. Now understand, x tend to 0 plus will get replaced. This will become limit theta tend to what? So here if you put x equals to 0, theta will become 0. Theta is also 0 over here. Okay, so now you just need to solve it. Sine theta by 2. So sine 0 by one more theta, theta by 2. So this will become 1. So overall 2 cancel. So pi by root 2 is your right hand limit. Perfect. Okay. Now let's talk about the left hand limit. For left hand limit, limit x tend to 0 minus fx. Okay. Or we can say that just put f of minus h, where h is a positive quantity, right? Because see, you are applying a negative sign already. F of minus h is what? F of minus 0.1. F of minus 0.1, here h will be a positive quantity. So basically limit will be f of minus h, where limit h tend to 0 plus only. So you will be wondering, ma'am, hold on, left hand limit, you're writing again h tend to 0 plus, but change, notice the change. F of minus h, I have already placed a negative thing in the function, right? Now again, if I just write now h, I have replaced x by minus h. Okay, so negative sign I have already inserted in. If I just say that, okay, h is also negative, so it will make a not in sense. So this will again will become 2 negative, that means right hand limit. That's why this can be written down as this. Understand the difference. There is a similarity over here. Okay, all right. Now let us put f of minus h. Let us just calculate the value. So this is going to be cos inverse 1 minus, then it is having minus h ka fractional part, and you will be having square of it. Perfect. Sine inverse 1 minus minus h ka fractional part, bracket close, whole upon fractional part of minus h and 1 minus fractional part of minus h square. Okay. All right. Now understand. You know that x is equals to GIF x plus fractional part of x. If x is equals to minus h, then what will happen? Okay. So your fractional part of x will become, okay, so minus h, right? Minus 0 point something. So for minus 0 point something, your greatest integer function will become minus 1. So this is minus 1 plus fractional part of minus h basically. And this is your minus h. Okay. So fractional part of minus h will become what? 1 minus h. Fractional part of minus x will become 1 minus h. Okay. So cos inverse 1 minus h ka square, sine inverse 1 minus h, then 1 minus h again, then 1 minus h ka square. That's it. Now let's expand one by one. This, if you expand, 1 cancel. So this is going to be minus of h square plus 2h. Perfect. This is sine inverse minus plus h whole upon 1 minus h, 1 cancel, h minus h square plus 2h again. Here h tend to 0 plus. Now start putting the values and understand what is happening. H tend to 0 plus. Understand. See. So now this is cos inverse minus h square plus 2h upon 1 minus h, and if you take h common from here, minus h plus 2 will also be here. Okay. Sine inverse h by h. What I did is I took h common from this denominator and I placed it in the denominator of sine inverse h, because sine inverse h by h is 1. Okay. All right. Now put h is equals to 0 here. Cos inverse 0. Cos inverse 0 is what? Pi by 2. If you put 0 here, it will be 1. Pi by 2 upon 1 and then 2. So this is pi by 2 by 2. Pi by 4 is your left hand limit. Okay. So now we can easily calculate 32 by pi square. Left hand limit is your pi square by 16, because pi by 4 whole square is this. Right hand limit will be what? Pi square by 2. And just take LCM or just multiply 8 by 8 here. So 9 pi square by 16 into 32 by pi square gone. 16 twos are, this is going to become 18. 18 as the right answer. Okay. All right. So a little bit lengthy question, I agree, because both limits were not that easy. One limit, if you calculate, it will not solve your problem. So that's why I will call it as a beta question. All right. Now we are having another question on our screen, which is saying that f of x is equals to x minus 1 when x is even and 2x when x is odd. Okay. If for some a belongs to natural number f of a is 21, then we are here to figure out limit of this quantity. Okay. All right. Clear. Cool. So from here, actually from this information and by using f of x, what I'll be doing is I'll be calculating the value of a. Once the value of a is sorted now, then this limit anybody will calculate. Okay, let's just give attention to the value of a. Okay, all right. So now f of a, okay, is equals to 21. All right, now how to solve? Because we need to attack over here f of a. What is the value of f of a? It depends whether your a is even or odd. So let's take two cases. Case number one, when your a is an even number. If your a is an even number, then your f of a will become what? A minus 1, right? And your a minus 1 odd number. Okay, a minus 1 will be an odd number. Let's keep that in mind. Okay, so in this equation, functional equation, in this composite function, I am going to replace f of a by a minus 1. Can I do that? Absolutely. Okay, this is equals to 21. Okay, now f of odd, this is an odd number. F of odd, hold on. F of an odd number, if your x is odd, right? If your x is odd, you will get 2x as your answer. So if your f of a minus 1, so if a minus 1 is an odd number, so twice of that quantity will be your answer. So 2a minus 2 will be your answer. Now 2a minus 2 is again what? Obviously an even number. Even number mein, how will you calculate? Just subtract 1 from it. 2a minus 2 minus 1 is equals to 21. So this is 2a is equals to 21 plus 3 is 24 and a will be 12. So from here your a is coming out as 12 and it is even only, so our case is actually pretty much validated also. A is 12. In this particular scenario we can calculate this limit now. Okay, so mod of x cube, see, we need to calculate limit x tend to 12 minus mod of x cube by a minus GIF x by 12. This is what you need to calculate, right? Okay, so x is 12 minus, right? So this is 12 cube, x is 12 minus upon a. A is what? A is exact 12. Upon 12 minus x by 12 will be 12 minus upon 12. So this is less than 1. So anything which is less than 1 which comes inside greatest integer function becomes 0, right? So this is 12 square only minus 0. So finally 144 will be your answer. So in this case 144 will be your answer. Now case number 2, when a is odd, that we will calculate, but see, our answer is matching. So that case might get rejected. So I'm not gonna waste my time and take that case. Okay. All right. Now we are having another question on our screen. Okay. So the question says, if A is this and B is this, we are here to look for ABQ. Very easy question, template based question. So many questions we have done in our notes as well. So this is the clear-cut question of rationalization. Square root of 1 plus root x power 4 minus root 2 upon x raised to power 4, limit x tend to 0. Okay. All right. Now, this is going to become a minus b root 1 plus root 1 plus x power 4 plus root 2. That's it. Root 1 plus root 1 plus x raised to power 4 plus root 2. Rationalization done. Now multiply. The moment you start multiplying, a minus b, a plus b, so 1 plus root 1 plus x power 4 minus 2 will be your numerator, and in the denominator x raised to power 4. Now, just here, if you put x equals to 0, what will you get? So ma'am, root of 1 plus 1, So that is root 2 plus root 2, 2 root 2. Okay. So now 1 and minus 2, if you further like manipulate, 1 minus 2 is minus 1. And this is 2 root 2 x raised to power 4. One more time you need to rationalize. Okay. Let's do that. So you need square root 1 plus x power 4 plus 1, square root 1 x power 4 plus 1. Again, same thing. A plus b, a minus b. So 1 plus x raised to power 4 minus 1. 2 root x raised to power 4. And now this, if you put x equals to 0, you will get root 1 plus 1. So just 2. 1 cancel, root x power 4 cancels. So you're getting 1 upon 4 root 2 as the final limit. So a is coming out as 1 upon 4 root 2. Okay. All right. Now let us talk about b, which is sine square x upon root 2 minus root 1 plus cos x. Obviously, x tend to 0, right? Okay, this is your b. Again, rationalize. Root 2 plus root 1 plus cos x. Root 2 plus root 1 plus cos x. Okay. So 2 minus 1 plus cos x and sine square x. This is root 2 plus root 1 plus cos x. Limit x tend to 0. Perfect. Okay. 1 minus cos x, then sine square x, then root 2 plus root 1 plus cos x. Okay. Limit x tend to 0. All right. The moment okay. Now 1 minus cos x can be written down as 1 minus cos x can be written down as, so this is sine square x. This is 2 sine square x by 2. Correct? Right? So now sine square x will need x square, but sine square x by 2 what? X by 2 whole square. So eventually I divided the equation by 1 by 4. So 4 is required over here. So this will be paired up and this will be paired up. Okay. So 4 by 2. So this will be 2. B will be equals to 2. Right? 2 1s are 2, 2 2s are 4. So 2. And here if you put x equals to 0. So this is root 2 plus root 2. 2 root 2 simply. So 2 root 2. So this is going to become 4 root 2. 4 root 2. Right? Yes. So B is coming out as 4 root 2. A is 1 by 4 root 2. Okay. So AB into B square, can I write? AB cube is AB into B square. A is 1 by 4 root 2. B is 4 root 2. So this will be 1. And into B square. So 4 root 2 square will be my answer. 16 to the 32 will be the exact answer of this question. Option B is absolutely right. Okay. All right. Now let's get into another question, which is this. Limit x tend to 0 and okay, so this is a reverse limit question. Usually in reverse limit question, we apply expansion. Okay. So I will make you recall all the expansion. Do not worry about it. So sine x 3 plus alpha. Sine x is what? Odd function, right? So it starts with 1. Okay, not 1. X. It starts with x. X minus x cube by 3 factorial. That's it. I don't think so. We need x raised to power 5 as well. Alternate plus minus sign will be there, and all the odd terms will be there. X raised to power 1, x cube, and so on. Plus beta times cos. Cos is an even function. So 1 minus x square by 2. That's it. We don't need any more terms. Let us stop it over here. Plus log 1 minus x. Acha. Log 1 plus x is x minus x square by 2 plus x cube by 3. There is no factorial in this expansion, first of all. And there is alternate plus minus sign will be there. It starts with x. So log 1 minus x if you calculate, it will have all the negative signs. Minus x square by 2, minus x cube by 3, minus x power 4 by 4, and so on. So this is minus x square by 2. I don't think again you need more terms than square. 3 tan square x. Now the smartest thing is you don't have to apply expansion for tan square x. Why? Because 3 tan square x can be written down as this is x square and this is x square, right? So this limit extend to 0. So this will become 1. So your denominator is 3x square. Okay. All right. Now what we will do is we'll focus on numerator. We'll collect all the terms. We'll write the constant term. Then we'll write the term x. Then we'll write the coefficient of x square, and that's it. Okay. So constant term is 3 from here. What is the next constant term? Plus beta is again next constant. That's it. 3 plus beta is constant. Now x wala term plus alpha and minus 1. X will be outside, plus x square wale terms. Here there is no x square, here also no x square, so minus beta by 2. So plus minus beta by 2, and this is minus 1 by 2 x square, plus there will be x cube wala terms which we are not clearly interested in. Limit extend to 0. Perfect. Yes. Okay. Now understand. See, if 3 plus beta is a non-zero quantity, then what will happen? 3 plus beta is non-zero quantity. Suppose 3 plus beta is 1 or 3 or 5, any other quantity than 0. Then there will be a big trouble, because 5 upon, can you see in the division there is an x square. 5 upon x square. 5 upon 0 square is an infinity. So this whole limit thing will not be a finite quantity. But as per the question, they have already given that this limit is a finite quantity. It exists also, and it is equal to 1 by 3. So in this whole expression, we cannot create any expression, any term which will lead to infinity. So 3 plus beta has to go away. 3 plus beta has to become 0, so that this term will not make the overall expression towards infinity. So 3 plus beta is 0. Beta is coming out as minus 3. First thing. So this is gone. Same. Alpha minus 1. It should be 0, because again x upon 3x square will be 1 upon 3x. 1 upon 3x. 1 upon 3 into 0. 1 upon 0 will become infinite. So this also has to be 0. So that means alpha minus 1 is equals to 0. Alpha equals to 1. This thing now, x square by x square, we are sorted. So minus beta by 2, minus 1 by 2, whole upon 3 should be equals to 1 by 3. If you put beta is equals to minus 3, so 3 by 2 minus 1 by 2. 2 by 2, yeah. So beta is equals to minus 3, satisfying this. So clearly we are having two values, 2 times 1 minus minus 3. So 2 plus 3 is 5. 5 is absolutely correct. Okay. All right. Clear. Perfect. So, and one more thing, there is a shortcut also to solve this question. See, in here, directly you just tell me which form is this, form, limits form. Obviously, 3 tan square x, so denominator is becoming 0. What about numerator? If you put x equals to 0, so this is 3 plus alpha sine 0, so 0, plus beta cos x. Cos 0 is 1, so plus beta, and log 1 minus log 1 is what? 0. So the numerator is coming 3 plus beta, denominator is 0. Now, if you want this limit to become an indeterminate form, because then only your limit will exist. If this is not an indeterminate form, then it will become infinity. Obviously, 3 plus beta has to be 0. Again, the same thing. Same reason. If 3 plus beta is 1, or suppose 2, or suppose 3, suppose 4, 5, 6, minus 1, minus 2, any other quantity than 0, then what will happen? Finite upon 0 becomes infinite. So this left hand side is becoming infinite. Right hand side is becoming 1 by 3. Is it even possible? No. So that's why 3 plus beta has to be 0. Become 0 by 0 form, and it is a solvable form. Okay. All right. So now, Now, this question is all about Leibniz theorem. Okay, Leibniz theorem. Let me just tell you first what is Leibniz theorem. So, Leibniz theorem is, suppose you have an expression which is, this is your gx, this is your fx, and this is your hx dx. So, suppose you want to differentiate a function which has an inbuilt integration. You want to differentiate this, and you know that differentiation and integration are anti of each other, opposite of each other. If you want to differentiate this now, then Leibniz gives a rule to differentiate this. In this, obviously, because integration and derivation are already there, they should be cancelling each other. So you don't have to integrate, you don't have to differentiate, but you have to follow certain rules while performing the action. So rule is hx. This is the function. So in this, sorry guys, sorry. This is h of t dt. Yes. Now, what will you do is, this is your h of t, right? T will be replaced by upper limit first of all. So h of f of x, upper limit. And now upper limit will be differentiated. Minus t will be replaced by lower limit, and lower limit is differentiated. That's it. So you are done, right? Let us just execute, then you will understand what is happening first of all. So limit x tend to pi by 2, right? Let me just write down. This is x cube pi by 2 cube cos 1 by t cube dt upon x minus pi by 2 whole square, and this is limit x tend to pi by 2. First of all, understand the question nicely. The moment you put x equals to pi by 2, so here you will put pi by 2, it will become pi by 2 cube. Carefully observe. If you put x equals to pi by 2 in the lower limit and in the upper limit, both upper and lower limit will become same, which will lead to the numerator part 0. See, if you integrate any function whose lower and upper limit becomes same, so the value will become 0, right? So this numerator is becoming 0, and obviously you can clearly see this is your 2, right? So pi by 2. So your basically your this is also becoming 0, right? So 0 by 0 form is getting created. So what we are going to do is we are going to apply L'Hopital to solve it. To apply L'Hopital, we have to separately differentiate denominator. So it will become 2x minus pi by 2, and we have to separately differentiate the numerator. Okay, so to differentiate the numerator now, to differentiate this integration of this thing, we will need Leibniz theorem. Leibniz theorem allows us to differentiate these kind of function. So cos of, now t will be replaced by upper limit. Cos of 1 upon upper limit is pi by 2 cube. So one more cube is already there. Pi by 2 power 6. Okay. And we need to differentiate the upper limit. See. So you have to put upper limit in place of t and then differentiate. The moment you differentiate upper limit, pi by 2 is constant. You will get a 0 minus. This time you have to put lower limit. You have to put lower limit in this. Okay. So that will become t will be replaced by, so cos of 1 upon, okay, cos of 1 upon t cube is written, right? So it will become, actually this should be 1 by t cube. There is some mistake in this question. Cos of, because if you replace t, so this will become, t will be replaced by x. X power 6 and 3x square. Okay. So this should be actually cos of, oops. Oh, we got it. No. There is some mistake in this question and I got this mistake, some printing mistake. So this is actually cos of t raised to power 1 by 3, right? Yes. Cos of t raised to power 1 by 3. Now do it. So yes, you replace, now 0 again minus. Replace t by what? X cube. So cos of x cube power 1 by 3 and differentiate the lower limit to 3x square. That's it. So this is going to become, and limit x tend to pi by 2 is there. Minus cos x, 3x square, 2x minus pi by 2. Right? Or we can say directly minus sign is, if you take common, pi by 2 minus x. Limit x tend to pi by 2. Right? Now cos x will be what? Sin pi by 2 minus x. So sin pi by 2 minus x upon pi by 2 minus x. 3 by 2 x square is already there. So limit x tend to pi by 2. So sin 0 by 0 is getting created again. So this is 1. 3 by 2. So this is going to become 3 by 2 pi by 2 whole square. So 3 pi square by 8, option C is absolutely right for this question. Okay. All right. Clear? Okay. Now let us quickly move towards the next question, which is this. Okay. Which says slope of this line is 27r1 plus 9r2 by 2. Okay. And in here, we are here to look for this limit. Okay. First of all, let us just solve the first half of this question. Slope of this line will be minus 45 by 5. You know the shortcut to calculate slope of any line. Minus of a by b, minus of coefficient of x upon coefficient of y. Minus 45 by 5. So minus 9 is the slope clearly. 27r1 plus 9r2 by 2 is becoming minus 9. Okay, let's keep it like this. Okay, a relation between R1 and R2 is done from our end. And now limit x tend to 3, integration of x to 3. Hold on. So this integration is only in the numerator. Again, the same Leibniz theorem wala game is here. 3r2x by 2 minus r2x square minus r1x cube minus 3x. Okay. So in here, if you see that again 0 by 0 form is getting formed, apply L'Hopital. So limit x tend to 3. If you differentiate the numerator, so t will be replaced by x, 8x square, and differentiate your upper limit minus. T will be replaced by 3, and the moment you differentiate lower limit, you will get a 0. So no need to perform that. Okay. Whole upon, now differentiate this 3r2 by 2 minus 2r2x minus 3r1x square minus 3. Now you put x equals to 3, right? So this is going to become 8x square whole upon. Now put x equals to 3 in the denominator. 3r2 by 2 minus 6r2 minus 27r1 minus 3, right? So if you solve this, 6 3s are 18 and 3 minus 18 is minus 15. 3 2s are 6. Minus 15r2. Hold on. 2x, right? 2r2x. R equals to 3. 3 2s are 6. 6 2s are 12. Okay. So this is actually, 6 2s are 12. Now minus 9r2 minus upon 2 minus 27r1, and this is happening minus 3. So this is your plus 9. 9 minus 3 is what? Your denominator is 9 minus 3, which is 6. So 8 3 square by 6 will be your answer, right? So this is 8 into 9 by 6. 3 2s are, 3 3s are, and 12 is the absolutely correct answer of this question. Okay, all right, yes. So just one time you apply the L'Hopital using Leibniz theorem and then just plug in the value of x, you will get your answer. That's it. Okay, and use the relation also. Chalo, let's move on to the next problem, which is this. F is a differential function. Again, same. Again, they have given you the same thing, which is again, we make use of L'Hopital and Leibniz theorem. So limit x tend to 0, 0 to x f of t dt upon e raised to power x square minus 1. My only concern is this x which is sitting in front of the integration, because we don't know how to handle it. We only know because this will then become the product of two different functions, right? So if you want to differentiate the numerator, be a different thing. I want to get rid of this x. Okay, so what I'll be doing is, let's do one thing. E raised to power x square minus 1. The denominator may, we need an x square, right? To complete this standard form, and we need to multiply x square also. So now at least, can you see? This is gone. So limit x tend to 0, 0 to x f of t dt upon x, and this e raised to power x square minus 1 upon x square, this will become 1. Now you can apply the L'Hopital f of x upon 1, because if you differentiate this using Leibniz theorem, it will become f of x. Upon, if you differentiate the denominator, it will become 1, and this will be alpha. Okay, f of x is becoming alpha. So f of x, and for x equals to 0 basically. So this is f of x, limit x tend to 0. So f of 0 is becoming alpha. Okay. All right. And f of 0 is alpha. So alpha is 1 by 2. It is already given in the question. You can see. So yes, 8 alpha square, 8 1 by 2 square will be 8 by 4. 8 by 4 will be 2. So 2, that means option B is absolutely correct. Right? Okay. Perfect. Let us move on to the next problem. Next problem. Okay. All right. Let A be the sum of all coefficients in the expansion of this. Okay. So this is a trick-based problem of binomial theorem. Then there is some combination of limits as well. Okay. Let A be the sum of all coefficients in the expansion of this, and B is equals to this, correct? If the equation cx square plus dx plus e is equals to 0 and 2bx square plus ax plus 4 is equals to 0 have a common root where CDE belongs to our DCE is equals. Okay. All right. First of all, the first half binomial part is very easy. If you are looking for sum of coefficients of something like this, any expression, just put x equals to 1. See, I'll tell you why. Suppose you are having an expression 1 plus x square plus x cube, whatever, power 2024. Okay. You're looking, you want that you expand this, and then each coefficient you want sum of the coefficient. Okay. I will write this in this form: a0 plus a1x plus a2x plus a3 x cube and so on. Right. So what do you want? You want, ma'am, a0 plus a1, sum of all the coefficients. That's what you want, right? So to get this, in this equation, if you put x equals to 1, you will get this only. Put x equals to 1. So you'll get 1 plus 1 raised to power 2024. Example. This is a different example, right? And this is, so 3 raised to power 2024 is equals to sum of coefficient. Sum of coefficient you will get the moment you put x equals to 1 in your expression. The moment you put x equals to 1, this is the trick. You will get 1 minus 2 plus 2 raised to power 2023 and 3 minus 4 plus 2 raised to power 2024. So this is going to become 1 raised to power 2023 and this is again 1. So sum of coefficient is very easy, 1. That's it. Okay. So A is 1. Now this B is what? Limit x tend to 0. 0 to x log of 1 plus t whole upon t raised to power 2024 plus 1 dt whole upon x square. So again Leibniz theorem, same thing, Leibniz plus L'Hopital. So b will be equals to, now just start differentiating this by using Leibniz law. Upper limit will be substituted log 1 plus x upon x raised to power 2024 plus 1. Derivative of upper limit is 1. So that's it, minus, now lower limit derivative is 0. So 0 ka derivative is 0. So this is 0. So we don't need to write it. Upon the derivative of x square is 2x. Limit x tend to 0. Okay. So now log of 1 plus x, correct, upon, so this is 2x and this is 1 plus x raised to power 2024. So this will become 1. If you put x equals to 0, this is gone. So 1 by 2 is the value of b. So you've got a, you've got b. So you've got this equation, which is, if the equation cx square, as per the question, cx square plus dx plus e equals to 0, and another is what? To be x square plus ax plus 4 equals to 0, have one common root, then what will happen? Now, very good question actually. Combination of 3 different chapters. Very good question. So b is what? Half. So if you put b is equals to half, this will become x square plus x plus 4 equals to 0. This and cx square plus dx plus e is having one common root. Okay. But if you carefully see this quadratic equation, this has imaginary roots. Right? So imaginary roots always occur in pair. It can never happen that only one root is common. So suppose a plus iota b and a minus iota b is its 2 roots, obviously. So one root cannot be common. If one root is common, second root will be, if you're saying that first root of this equation is a plus iota b, then second has to be a minus iota b. What does that mean? That one root is common, but on top of that, second root has to be common. Why? Because it is having imaginary roots, and imaginary roots cannot stay alone. Remember the nibba nibbi concept. Nibba nibbi, nibba will go where nibbi will go. Nibbi will go where nibba will go. Okay, so if somebody is saying nibba is there, so you just identify. Nibbi must be here. Okay, only nibba is not there. Nibbi must be here. Assumption, definitely. So in mathematics, there is no assumption. There is short thing. If a plus iota b is common, short a minus iota b should be common. Both roots are common. Both roots are common. That means C ratio D ratio E has ratio 1 ratio 1 ratio 4. 1 1 4. 1 1 4. Option D is absolutely right. Very, very good question, I would say. 3 concepts. All 3 are tricky concepts. Okay. So yes, tricky, but again, not very lengthy. If somebody knows it, then it is easy to solve. Okay. All right. Now this question. So let me just rewrite limit x tend to 0 e power 4 mod sin x minus 2 mod sin x minus 1 upon x square. Now this limit is equal to minus 1 or does not exist or is equal to 1 or is equal to 2, that we need to figure out. Okay. So in here what we will do is put sin x equals to t. In fact, mod sin x equals to t. So e raised to power 4t minus 2t minus 1 upon this will become, okay, x square. So here what we will do is, see in the original question, can I just multiply sine square x upon sine square x so that this is gone, this will be 1 and this is your t square. Right? And this is sine x by x whole square. Right? So this is limit x tend to 0 and this is limit c. Now t is mod sine x. So t tend to 0 plus. Now this, if you separate it out, this is minus 2t, right? E raised to power 4t. Okay, so e raised to power 4t minus 1 minus 2t. This is t square. This is also t square. Okay. Or what we can do is we can just simply apply the L'Hopital on it. 4 e raised to power 4t minus 2, that's it, upon 2t. Is it 4 or is it 2? Hold on. Yes, so I guess there is some mistake in this question. Let me just rewrite. Let me just rewrite this question. Limit x tend to 0, e raised to power, this is actually 2 mod of 2 sine x minus 2 mod sine x. Yes, this is the original question upon x square. What I'm going to do is multiply sine square x by sine square x, so that these two things will become 1. So limit x tend to 0, e raised to power 2 mod sine x minus 2 mod sine x upon mod sine x square. Okay, and this is sine x by x square. Perfect. Okay, now if you put, this is e raised to power 2 mod sine x minus 2 mod sine x upon sine x whole square, right? So what we will do is we will put mod sine x equals to t. So this is e raised to power 2t minus 2 mod of t, again mod, no need, whole upon t square. Limit t tends to 0 plus. So this is 2 e raised to power 2t minus 2 upon 2t. 2 if you take common now, then what will happen? This is 2 if you take common, this will be 1. So now this will become 1. So this is coming out as, so the final answer of this question is 2 only. So limit does exist and it is equal to 2 will be the final answer. Okay. So there was a mistake in this question. 2 is absolutely right. So this part we have applied the L'Hopital. Okay. All right. Perfect. Now we are having another question, which is saying that there is a function f, which is a strictly increasing function, such that limit x tend to 0, infinity, f of 7x by f of x is coming out as 1. Now understand that because it is an increasing function, f of 7x, f of 5x, because it has been used in the question, and f of x, 7x will be much greater than 5x than fx. Okay. Now if I just divide the whole thing by f of x, what will happen? Since positive function in inequality, I can divide with a positive number. So f of 7x by f of x greater than f of 5x by f of x greater than 1. Okay. So limit, now they are saying that this thing is equals to 1. Limit x tend to c. What is happening if I apply limit on each and every side? So limit x tend to infinity, f of 7x by f of x greater than limit f of 5x upon fx, x tend to infinity, and this is greater than 1. So this is 1 and 1. With the use of sandwich theorem, we can say that this thing will become what? This value. So so this value will be 1 only. 1 minus 1 GIF will become 0. 0 is absolutely right. Okay. So 0 is absolutely right. 1 minus 1. Okay. All right. Perfect. Next question. Let us move towards next question. So here we are having again the reverse type question. So expansion we will use ax square e raised to power x expansion. So we all must know. Okay. And in this question, we have to just go till x cube. That's it. Minus b. Log 1 plus x minus x square by 2 plus x cube by 3 plus cx e raised to power minus x 1 minus x plus x square minus plus x square by 2 minus x cube by 3 factorial factorial. That's it. Whole upon x square sine x. Okay. So x square now sine x. X by x. So this is 1. So niche there is an x cube, right? So now just let us just club the terms together, right? So just club all the terms which have a constant term. So there is no constant term in this equation. Is there any term which is having just x? Yes, minus bx. That's it. Oh, sorry, plus cx is also there. Term related to x. So basically c minus b times x. C minus b times x. Now x square related terms. So ax square. So plus ax square. And then plus b by 2. And from here minus c x square. Now x cube related terms. So this into this will work for us. Ax, okay. That's it. A will be the x cube term. Minus b by 3. And okay, cx. So this is plus c by 3 factorial. No, minus c by 3 factorial, right? Minus c by 3 factorial x cube whole upon x cube. Sin x by x is anyway going to become 1. Again, the same concept, same logic we are going to apply, that only x remain in the numerator, everything else will become 0. So this will be 0, this will be 0, and this will be equal to what? 1. Because x cube cancel out, and this coefficient should be 1. Let's apply. Let's just do. So b equals to, see, this is your first thing. Very good. A plus b by 2 minus c. A plus b by 2 equals to, see, this is your second. So basically a plus b by 2 is equals to b only. So a is equals to b by 2. This is actually your second. And this is the third one is a minus b by 3 minus c by 6. So a minus b by 3 minus c by 6 is 1. Now b and c are equal, right? So a minus b by 3 minus b by 6 equals to 1. And a is also b by 2. So, or b is equals to 2a. This also we can write now. So b is equals to 2a. 2a by 3 minus 2a by 6. 2a by 6 is what? Is equals to 1. So a minus 2a by 3 minus a by 6 equals to 1. Sorry, a by 3, right? So a minus, this is going to be 3a by 3 equals to 1. So minus 2a is equals to 1. A is minus 1 by 2. A is coming out as minus 1 by 2. If a is minus 1 by 2, b is 2a. So b is minus 1 and c is also minus 1, right? So the values of a, b and c which we have calculated is not matching actually. B by 2 plus a is equals to c. And the third one is a minus b by 3 plus c by 2. Okay. So there is some okay, all right. I have made a mistake over here. Instead of 3 factorial, because x cube I will be forming by this. So this is c by 2 only, the last thing. So this is c by 2. This is wrong, c by 2. Now we have to redo everything. Do it. So b and c are equal. A minus b by 3 minus b by 2 is equals to 1. A minus 3 to the 6, 5b by 6 equals to 1. Now b is 2a. So again a minus 5 times a by 3 is equals to 1. So minus 2a by 3 equals to 1. A is equals to minus 3 by 2. A is, hold on. A minus, let me check, minus b by 3 plus, and it is having actually plus c by 2, right? Plus c by 2, plus c by 2. Oops, again. A minus, this is 6 minus, so a plus b by 2 minus b by 3 equals to 1. A, then we are having plus 6, 3b minus b by 6 equals to 1. So this is a plus 2a by 6 equals to 1. So 3, 4a by 3 equals to 1. A is 3 by 4. A is 3 by 4, right? And now B is 2a, so 3 by 2. C is also 3. Oh, now it's absolutely fine. 3 by 4, comma 3 by 2, comma 3 by 2. 16. 9 by 16 plus 3 by 2 ka square is 9 by 4 plus 9 by 4. 16 से if you multiply 9 plus 4 9s are 36 plus 36. So 72 plus 9 is 81. Oh yes, 81 is absolutely right. And with this, we are done with all the 11 questions in like very short time. All right. And also do not miss out on the MVSAT examination, which is happening, which already happened in September ending. But now we have another chance. We can give this exam in the first week of October. Link is given in the description box. That is first thing. Okay. Second thing is, if you're looking for chapter-wise source of JEE Mains 2022 and 2023 solutions, JEE Mains PYQs, then just go for Tatva books blindly. Physical books you can just order. Link is again given the description box. Okay. And 2024, so we are just creating the playlist. We are doing it left, right, and center. All right. And third thing is, if you have any doubts, you can reach out to me via my Telegram channel, t.me/Namrata Jaisinghani. Yes, t.me/Namrata Jaisinghani. This is my Telegram ID. So you can just ping me here and we can have a fruitful discussion, whether it is academic or non-academic doubts. Okay. Now this is me, Namrata, signing off. I'll see you all in upcoming video. Also do comment that which video you want to see next in this particular series. See ya. Bye bye.